Hello, my viewers. My name is Sadiq Tijani. I'll be explaining differential equation. Before I start explaining what order and degree of a differential equation is, I will need to give a brief definition of differential equation. Now, what is differential equation? A differential equation is the relationship between variables and their derivatives. So that is differential equation. Now, today I will explain order and degree of a differential equation. What's an order of a differential equation? An order of a differential equation is the highest derivative present, while degree is the power to which that highest order is raised, provided that the equation is written as a polynomial in its derivatives. I will explain what they mean by the equation should be expressed in polynomials. Look at this first example. We are given the y ds to be equal to exponential raised to power s. Now, if you look at this dy ds, the highest power of this derivative is an invisible one. There's an invisible one here, which shows that this is of what? Order 1. It's of what? Order 1. Because the derivative here has what? An invisible one. Now, let's look at this example 2. This is a differential equation. The highest order of this differential equation is what? 2. Because the power here is 2. So this is of order 2. Now, looking at the third example, we have raised to power 3 here. We have raised to power 2 here. Now, from the definition of order, an order is the highest derivative present. And the highest derivative here is what? 3. So here we have order what? Order 3. And for the last one, we have xy raised to power y, xy, y double prime, plus x, y prime square, minus y prime. I believe we all understand the fact that y prime is equal to the y ds. And our y double prime means the square y all over the x the squared. So if you understand this relationship, or this y double prime is the same thing as second order differential equation, and y prime is the same thing as first order differential equation. Definitely, if we have y triple prime, that will be what? Third order differential equation. So the equation here, because the highest order here is 2, so we have order of 2. So I'm writing this differential equation in this form because the y ds can be written in form of the y ds or y prime. It can also be written in form of what? Y double prime. So that's how to determine the order of a differential equation. Now, how do we determine the degree of a differential equation? From the definition on the board, we have a degree is the power to which that highest order is raised. Now, let me just give you an example from number 3. Number 3 here, we have the highest order here is 3, right? And we have third order here, we have second order here. If you look at the second order, it is raised to power 3, while third order here is raised to power what? Is raised to power 1. So the degree is 1. The degree is 1 because the highest order will determine the degree of a differential equation. The highest order will determine the degree of a differential equation. So the highest order here is 3, and the degree will be 1. So let me give you another example. In a situation whereby we have something of this form, the 5y all over the x5 plus maybe 7 the y the x plus equals x squared, for instance. This is of order 5. This is of order 5, and the degree is 1. The degree is what? 1. Because the highest order determines the degree. The highest order will determine the degree of a differential equation. Now, in some cases, degree will not be determined if it's not expressed in a polynomial form, as stated in the definition earlier, that provided that the equation is written as a polynomial in its derivatives. So in this example we have on the board, we have example 5, 6, and 7. Though this is second order, this is first order, and this is second order differential equation. But we cannot determine the degree of this equation because the example number 5 is trapped in what? In a sine function. While the variable here, which is a dependent variable y, is what? Is expressed in exponential. So the degree of this equation cannot be determined. So in a differential equation that is not expressed in polynomial, the degree cannot be determined. Thank you so much for paying attention to this class. In the next class, we are going to continue on how to solve first order differential equation.